I'm Caden.
And I'm Chris.
And this is our
final project.
Okay, everyone. This is not everything that we've learned this whole semester, but we're going to talk about as much as we can in this short video.
We're going to talk about metamorphic rocks, igneous rocks, volcano. We have a special guest talking us through all three of those, including volcanoes.
And the last three are weathering, faults, and disconformities.
So hope you guys enjoy this video. Let's
sit back and grab the popcorn.
That's just a stupid boulder!
It's not just a boulder! It's a rock! A rock! A rock! It's a big, beautiful, old rock. Oh, the pioneers used to ride these babies for miles, and it's in great shape.
And next, metamorphic rocks.
Dun, dun, dun.
Metamorphism has to do with alteration of the composition or structure of a rock. There's three basic agents to metamorphism. The first is heat, pressure, and fluids.
Two types of metamorphic rocks are foliated and non-foliated. Foliated rocks have to do with the alignment of minerals within a rock, and non-foliated rocks are classified based mostly on that they don't have layers. Some different types of foliated rocks are slate. Slate is from an old French escalate or éclate, which means to split or break. It's very fine grained, breaks into flat layers, and has a dull luster. That comes from the parent rock mudstone. Another one is gneiss. It's from an old High German Gneisto, which means spark. It's coarse grained, has bands of color, and its parent rock is schist, granite, or diorite. A type of non-foliated rock that's commonly known would be marble. Marble, perhaps related to the ancient Greek, marmoios, means gleaming. Its composition is mostly calcite, it's soft and reacts with acid, and its parent rock is limestone.
Boring!
And now, igneous rocks.
Alright, so up next we got intrusive rocks. Intrusive rocks are formed from the solidification of molten rock material. There's two basic types of igneous rocks. There's intrusive and extrusive. Intrusive crystallize in the Earth's surface. They cool a lot slower, which allows them to form large crystals. And then the extrusive erupts on the surface, and it cools a lot quicker, and there's smaller crystals. Hey Chris, look at those rocks you're sitting on.
Wow, you know what that reminds me of? We have special guest Tonio Cuti talking to us today about volcanoes.
Okay, let's start. Volcanic, real fast. This is blown out. We call this a volcanic bomb. So it's spindly. It shoots it up into the air and it solidifies and it rolls down the slope and makes that particular shape.
Wow.
There's two types of volcanic material here. You have sharp and angular. You can see it if you walk on it. They call it sharp and angular. This is Pahoy Hoy. Here's pumice, and pumice is vesicular, so a lot of air is passing through the rock.
So it's very light?
It's very light.
Oh, wow.
Okay? A lot of times pumice can be blown literally thousands of feet into the air. Okay? Now, if that's pumice, here's scoria. So the gas pockets are here, only now it's darker. So this is the mafic side of the chart, while pumice is on the felsic side of the chart. Okay, you can see the size of the gas pockets. Here's pumice from Mount St. Helens. By accident, this was borrowed from the park. All right. I did ask the park ranger for a sample because I was an earth science teacher, and he said, well, we can't give out samples because if we did that, then of course we wouldn't have it in any park. He said anything you find outside the park boundary, you can pick it up. This was wedged alongside of a tree about 50 yards from the exiting of the park, and I happened to kick it, and it just rolled out through the gate, and there it was, ready for us to take it home.
Clever.
Okay? Okay. All right. Here's ripple marks. You can see the ripple marks on the rock. That used to be water sloshing back and forth. Okay. And so as the sand hardened and, you know, the cement that we talked about in class, the calcareous, the siliceous, the ferruginous, all those minerals in there, locked it up, and you get these nice ridges.
What kind of water with the environment would that cause it to do?
That would have been probably in some type of a stream bed. Okay, would have been in the stream. Here's mud cracks. This is mud cracks, and we call this a mudstone. You grind it up, and it would be. It's in the shale family, so the muds, the silts, and the sands are all on here. And when the water evaporates, of course, mud is made of clay, so it expands out. As it expands out, sand fills in, and you get this little spider network in there.
Wow.
All right.
Hey Chris, come take a look at this.
What is it?
We got some rocks that are not together. It's called mechanical weathering.
Really? What is mechanical weathering?
Mechanical weathering is when rocks split into smaller pieces and the chemical balance is the same.
Wow. Do you have an idea what type of chemical weathering this is?
Not sure exactly since I wasn't there when it happened, but I would go on a limb and say biological weathering. Chris, take us away with anticline, syncline.
Here we have an anticline. It's young on the sides and old in the middle, and the sides are exposed to the elements. That's it. Here we have a syncline, where it's young in the middle and it's old on the sides because the middle is what's exposed to the elements.
This is the worst.
Here we have the hanging wall. Here's the foot wall. This would be a normal fault. This is a reverse fault due to pressure.
Up next, unconformities.
Burn one tire off.
Nonconformities.
I had to buy her a new.
Nonconformities are unconformities that separate metamorphic or igneous rocks from overlying sedimentary rocks. So that means it's like this.
Disconformity. So next we're going to be looking at Kelly's patented two-step process to identifying unconformities. Chris talked about nonconformities, so we'll skip the first step. So moving on to step 2, are the rock layers directly above and below the unconformity parallel? Yes, then that's disconformity.
Angular.
Oh no, that's a.
Angular pretty much is the easiest unconformity to tell because it's not parallel, it's angular.
Easy enough, you know. If you have any more questions, ask a librarian.
Appreciate it.
Okay. Thanks, guys. It was a
Pleasure
good
doing
semester.
business.
Yes, it was.
All right. And Miss Wakefield, it's a solid A for him. Solid A.